Bismillahirrahmanirrahim. Today we will discuss about the power calculation of a reduction gear train. So before going into its detailed calculation, I have drawn a schematic diagram of motor which is coupled with the gear train. The gear train then rotates the other required device. Here we denoted the input RPM of the motor by N1, the input uh, torque of the motor by T1, and the input power of the motor is by P1, and the output RPM of the gear by N2, the output torque of the gear motor by T2, and the output power of the gear by P2. So here we must know some parameter before going into its output power. Here the motor RPM in this case is 1450, gear ratio 45, gearing efficiency 85%, input torque, which is oftenly written on the nameplate of the motor, is 400 Newton meter. The required parameter is gear power. Solution. As we know that the output power means the power is equal to torque multiplied by angular velocity. Angular velocity is then again equal to 2 multiplied by pi multiplied by RPM. So also the gear ratio is equal to the input, means uh, the input RPM divided by the output RPM of the gear, which is in turn equal to the output torque divided by input torque. So here first we have to calculate the actual torque which is obtained at the output shaft of this gear. So here uh, first we calculate the ideal torque. Ideal torque is equal to the gear ratio multiplied by the input torque, which is equal to 18 kilonewton meter. So uh, we know that not all the torque, input torque, is converted into the output torque. So there are some losses in the gear train. That's why we oftenly take the gearing efficiency from 80 to 90%. So in this case we have taken the gearing efficiency is 85%. So by putting this value we obtained 15.3 kilonewton meter output torque. Similarly, the output RPM is also uh, find out through the same formula. So here N2 is equal to output input RPM, yani motor RPM divided by gear ratio. So here we obtained the output RPM at the output shaft of the gear is 32.2. So to find the input power here, we use the same formula: input torque multiplied by 2 multiplied by pi multiplied by input RPM, means motor RPM, divided by 60. So the by putting all this value, we get the answer 60.9 kilowatt. Now we also know that not all the input power is converted into the output power. So there are some losses in the gear train, as in case of the previous torque example. So to calculate the actual power obtained at the output shaft of the gear is 60.9 multiplied by 0.85. 0.85 means 85% efficiency of the gearing system. So multiply both these value, we get 51.76 kilowatt, means this is the actual power obtained at the output shaft of the gear. Thank you.